Department of Artificial Intelligence and Data Science. Today we will use a design thinking approach to build a relational database for a university library system. It starts from user needs to final schema. Instead of jumping into SQL, we will first empathize, define, ideate, prototype, just like real system designers solving real problems. First one is empathize. Today we are exploring how databases help solve everyday problems. Let's start by thinking about your experiences in a university library. What challenges have you faced when borrowing books?
And sometimes the system says your book is available, but when I go for picking up, it is missing.
Sometimes I forget to return the books because I don't get a clear notification.
And sometimes it's confusing how many books can I borrow from the university library.
These are classic examples of data management issues. A well-designed database can help solve this by keeping accurate records and enforcing rules. Second one is define. Great insights based on that. Our goal today is to design a relational database that manages library operations, tracking books, members, and loans, while making sure the data is reliable and easy to use.
So basically, we need a system to know who borrowed what and when it is written.
Exactly, and also make sure books are not double booked or lost in the system. Third one is ideate. Let's brainstorm the main things we need to track. What entities do you think are involved?
So the first entity is books now. It contains attributes like title, author, and ISBN.
And second entity is members one. The members in details contains students or faculty who borrows the books from the library system.
And the last one is loans one, which contains a record of which member has which book and when.
Perfect. So we have three main attributes: book, members, and loans. What attribute should each have?
For a book, we need an ID, title, and author, and even maybe the journal.
So for members, we need member ID, contact information, and their names too.
And for loans, we need the book ID, member ID, and the date and the return date.
Good. Now do these entities relate?
Yes, ma'am. So, and later a member can borrow a book, ma'am, but a book can be assigned to a single person.
Right. That is one-to-many relationship from members to loans.
Should we track who processes the loan, like library?
Excellent idea. That could be another entity or an attribute in loans. Fourth one is prototype. Now let's translate this into relational schema and write some SQL commands. Here is how we create the book table. Create table books, book ID, int, primary key. Title, varchar of 100, author, varchar of 100, genre, varchar of 50. Here, create table books. Here, books is a table name. Book ID, int, that is stored as a numeric value, and it is a unique number because we given as a primary key. Title is used to store the name of the book, that is in a string data type. Then next one is author. Author varchar of 100. Author name also store it as a string. Then genre varchar of 50. This one also store it as a text.
And what is unique identifier?
The unique identifier for each book is book ID in book table. Now the members table. Now we will see how to create members table. Create table members. Here members is a table name. Member ID int primary key. Member ID is the column name. Int is the data type. Primary key is an key. It is used to uniquely identify the member ID. Name is an column name. Varchar is an data type. 100 is the size. The next one is contact. This is the column name. Varchar is the data type. 100 denotes the size. Here we are storing member ID, name and contact.
Can no link between the members and the books, ma'am?
Exactly. Here is the loan table with foreign keys. Now we will see how to create loans table. Create table loans, loan ID in primary key. Loan ID denotes column name, int is and data type. Primary key is used to uniquely identify loan ID. Book ID is a column name, int is and data type. Member ID is in column name, int is and data type. Loan date is in column name, date is and data type. Return date is in column name, date is and data type. Foreign key of book ID references books of book ID. Here we are referring the books table to collect the information from books table using book ID. Foreign key of member ID references members of member ID. A foreign key is a field in the table that references the primary key in another table.
I have a question. What if someone tries to learn a book that has already been learned up?
Good question. We enforce rules in the application or use constraints any queries to check availability. Let's try a sample query to insert a new loan. Now we are going to insert values into loans table using insert command. Insert into loans, loan ID, book ID, member ID, loan date, return date. Values 1, 101, 201, 15/7/2025 is the loan date. 30/7/2025 is the return date. Using these values, storing the data into the loans table. Fifth one is test. Now that you have seen how the tables and queries work, what challenges do you think come up when managing data integrity here?
Making sure books are not loaded twice at the same time.
Ensuring that the return dates are recorded correctly.
And preventing duplicate members.
Exactly, that's why keys, constraints, well-designed queries are critical. To wrap up, good relational database design helps keep data organized, reliable and accessible. Exactly what a university library system needs. Thank you for your input and participation.